Hey everyone, welcome back to my channel. This is Lakshay here. So today we're gonna start with our lead code question number 139. It says word break. Okay, so let's read what this question says. It says given a string S and a dictionary of strings, return true if S can be segmented into space separated sequence of one or more dictionary words. Note that the same word in the dictionary may be reused multiple times in the segmentation. Okay, so what this question says that we will be given a string S and a dictionary of word like this, and we have to check that can we segment our string into like this. Means if we segment our string, so can we get all the words like this? Let's take this example only. So we are having an example here like this lead code. So if we bring so we have words like this lead and code. Okay, so we can break it only in this way only. So that means we can break our string like this lead and then code. This is the way we can break. We can't break it like this lee like lee, and another string can be tc and ode. We can't break it like this because these words are not present in our dictionary, but if they were present, then we would have break it like this, but they are not, so that means we can't break them like this. That's why there is only one possible way, that is this is how we can break our string, and that's why we will return true. Let's take another example. Let's take the third example. Okay, here we are having string cats and dog. Wait a second. Okay, and we have words like this cats, dog, sand, and cat. So if we break it like this, we can see that cat is present in the our dictionary, so we can break it like this cat. Then we can check for sand sand. We can see that sand is also present, but the og we can see here this is not present in our dictionary. That means we can't break it like this. Let's try another method. If we break like this, first we break cats because it's present, then we break like this a and d because it's also present, but again we left with og. So that means we can try all possible ways, but we can't form this string with the help of the words of our dictionary. That means it will definitely return false. Okay. So how can we approach this problem? So with the help of recursion we can definitely with ease we can approach this problem. So let's see how we gonna approach this. Let's take this is first of all we are having empty string, and this is our string like this lead code, and we will form a unordered map. Okay, first of all we will form an unordered map, or you can say set. Yes, you can say set. We can form an unordered set where we will push our words that we are having in a dictionary, so that we can quickly check that if we are having these words in a dictionary or not. Okay, so let's see what are our words. So our words here are lead and code. These are words of our dictionary. Okay, that means we will push them in our set. Let's see, and at starting we will point our index at I. So at I here, we will start checking that if we break a string like this, like we break L like this. So does our L is present here? If not, then we will not move forward, and our index basically moves further. Okay, now it points here. Our index here is initially at start, and now our I pointer is now moving forward. Okay, now see. Now if we break like this, does this substring is present in our set? No, we can see. So that means we can't move further. Then we will again check for the next like this. Sorry, we will check. We can see that it's not present. Okay, so that's why we return from here. So we will again check for the next I. So I is moving like this. Okay, cool. Now we can see that this is matching. Okay, so once we find that this is matching, then our index moves. Okay, now our index moves to I plus 1 like here. Our index is pointing here. So that means this function calls now again calls this function, and it will check for the code. Okay, that is, this can be a matching or not, like this. That now where we should be breaking this. So we know first break we put here. Now we will try for here. Like, can we break like this? But we know that we can't break it like this. Means, wait a second. This is like this. Okay. So let's take the code part only. So can we break it like this? So we can see that we cannot. So our index was initially here. We checked for this part. Now index moves further, like here. Oh, so now it again checks that can we break like this. We can check that this substring is not present. That means we can't. So I moves further. Now it will check again. Can we, it can be broken like this? So we can see that no, it can't be. Okay, because this is not present in our set. So then I again moves further. So in this case we can see that yeah, we can break our strings like this. Okay, so that means yeah, we can move further. So when we move further, we can see now our index, because index will be always I plus 1. That means because we are now checking for the next index now. That's it. Now we can see that our index has reached the length n, means now our I has reached n. That means we have successfully found a way to break our string, and this is our way. You can see we successfully find that way. That means it is possible to break our string in the form of words that are already present in our dictionary. That's why we have reached to our n. So means we can simply return true from here. Okay, so when it returns true, it gives true, then it gives true here, and it gives true at the end here, and at last we returns true. Okay, simple. So this is how we're gonna approach this problem. It's pretty simple, I guess. Let's now jump to our pseudocode. I will tell you the code how this is actually working. Okay, first of all, this will be our main function where we will be given a string and our word dictionary, you can say. So first of all, we'll find the length of a string. It will be string dot length, and then we will create what we know, a set. So unordered set, we will push our word dot begin till word dot end, like this. Okay, after this we will call our function that will be give our answer. That will be, we will simply return that solve, and what we gonna pass it. First of all, our start index, we will start gonna with 0 index. That's why 0 and 1. What else we can pass? We'll pass a string length, and then our string and our set, that is this. Sorry, we haven't named it something. So what can name we can name is, we can name it as word dictionary, or we can simply say dictionary. Okay, you will name it dictionary. When you will form it, you will definitely gonna name it like this. This, and sorry, you will see the initialization below code here, because we are going to initialize this like this. Another set, then you can write it here whatever, you can string, and then here you can give your name like this dictionary, and then you're gonna write these line here. Okay, so this is how you're gonna create your set. Okay, so now let's see how this solve function is working. So in the solve function we will have a start, which is initially at 0, and our size basically of our string, and s, and our dictionary that we basically are set. So what will be our base case? Our base case will be when our start reaches to n. That means we have successfully traversed the whole string, and we have formed our word with the help of the dictionary. That means therefore we will definitely return true from here. But if that's not the case, then what we will do? Then we will start traversing, means we haven't reached the end. That means we have to traverse furthermore for the next indexes. That's mean, so for that we will start a loop for int I equals to start, and we can go till n and keep on I plus plus. But how we are gonna check? First of all, we will have to create a empty string. Let's name it temp, and we will store our words. For example, we are having lead code now, so we will store first L. Let's write it here. So we'll create a string temp. Okay, and at every index we go, we push our value to our temp, like this, temp dot pushback. our s of I. Okay, so that means now our temp is holding L, and then we will check for L, that if where we have to check dict dot find what our temp equals to dictionary dot end is not equals to dictionary of end. Okay, it means that we have found that word, but as you can see we haven't find it here. So we will now push the another temp here, means another index. Now I is moving here, then it pushes here, then I moves here, it push here, then I moves here, push here. So when we see that lead, so when it checks, it will find lead here. So if it finds it, then we move forward further, and we will create a bool answer variable. And what we will call the function for the next index here, like this. Solve will be called for our I plus 1, because till I is here now. We already found the string, so now we are checking for the next index I plus 1, and same n s in our dictionary. And if now we have started checking, this means our function again calls till from here. So now it checks, so if it returns true, that means that we have successfully found our thing, so it will also return true. So that's why if answer means true, then we will return true, means our function has returned true. That means in short we are going to return true. But if that's not the case, we will directly return false. Okay, means we have our for loop has ended here, and we haven't found true, means our all cases are failing. That means at the end we will return false, means we can't form this string with the help of the bag of words which we are having in our dictionary. Okay, so that's it, this is our pseudocode. So let's see the time complexity. Okay, so the time complexity will be exponential, which will means big of 2n, because for each case we are checking so many of times, that leads to an exponential time complexity, which basically gives you a time limit exceed problem. That's why we have to memorize our recursion. Okay, so how we gonna memorize? So the memorization is pretty simple. What we have to do, we have to just declare a dp array. Okay, so we will declare a dp array of size n plus 1, and initialize it initially at to -1. Okay, after that we will pass our dp in a function also, like this. We are passing dp here, so then our dp here also. And before performing anything, means after the base case, we will have to check like this, that if dp of start is not equals to -1. If not equals to -1, that means we have already solved this problem. So we will return dp of start from here, the value which is stored in our dp of start. Okay, why we use memorization? Basically we are using memorization because there are many overlapping sub problems here. Let's take example like this, lead code lead. So when we checks for lead, then we checks for code, then when we again checks for lead, we know that we have already solved this problem. That's why we don't need to solve it again. That's why we use dp to store the answer for the overlapping sub problems, so that we don't have to do recursion again and again, which leads to our time complexity increasing. Okay, means basically it leads to our exponential time complexity. Okay, so this is how we're gonna approach. So we wrote here, align this. Then again we have to write here also that return dp at start equals to true. If we got our answer equals to true, then we will simply return dp. But if we haven't, then we will return false, like here dp of start will return us false. Okay, so this is how we're gonna approach our this problem with the help of memorization. Recursion will not work because I have already told you that this will lead to time limit exceed. That's why we have you with the help of dp and memorization, we will deal with this problem. Okay, so now let's see the code below, which is same similar. Let's see here. Okay, so first of all, this is our main function. Okay, word break, where we passing a string and our word. Then first of all, we'll find our length of the word, sorry, string. Then what we have done, we have created a set that we have already discussed, where we pushed our verdicts, means all the words of a dictionary we have pushed to our words. That is our set basically. And then we create a dp of n plus 1 size, which is initialized with -1, and then we are calling our function solve. So now we are calling function here. So first of all, the base case, like we discussed, if our start has reached to the size of our array, sorry, string, then we will simply return true. But if that's not the case, Then after that we will check that if have we already solved this subproblem before. If we have solved this subproblem before, then we will simply return our dp value, means the value we have stored on that part. Means we have solved this subproblem before, so we have stored this somewhere now that it returns true or false. So we will simply go and check that what we have stored there and simply return from here. Okay, but if that's not the case, that means we haven't solved this problem before. Then we will start by creating a temporary string, and then one by one pushing values and checking that. First of all, we'll push L and checks that is this word present there. If not, then we push lead le, then also checks. Then lee means once another e, then checks, then another t, and then checks. But after that we see that lead is present, then it presents, then again we call the function but with the next index. You can see, means it was like this now. So we call for here, then again checks that if it returns true, means the answer is storing the next index solution. So if it is true, that means our value is true, and if all this iteration we didn't get a true, that means we can't form our string with the help of these words. That's why we will return false. Okay, so that's it. This is how you're gonna approach this problem. Now let's see now what is the time complexity. So the time complexity will be bigger of n square. You will be thinking how this is possible. So let's see. This is because it is taking n and n. First n will be size of our dp, means n traversal now. So it will be a size of our dp which we are initializing, and then n is the n times we are traversing. Each box we are traversing n number of times. That's why this is the db. Okay, because how so? Because we know that at when we are at like this now, at this index we are checking for all this, then we are at this index, then we are again checking for all this. So we are checking each dp many number of times. That's why big of n square. And what is the time space complexity? Space complexity will be big of n plus big of n plus big of n. Also, this is for the dp, this is for the recursive set, sorry, recursive stack, and this is for our set. So this is our space complexity. Okay, and this is the time complexity. So that's it. You can write this space complexity like this, only approx big of n only. That's it. That's how we're gonna approach this problem. This is your code. You must try the dry run by yourself also. That's how you're gonna get a clear view of this problem in your head also. Okay, so that's it. See you in the next video. Till then, stay safe. Bye bye.